Good morning, guys. Welcome to today's lesson. I hope you're enjoying yourself so far. Today we're going to do a quick review of algebra. Pretty straightforward, not that hard, but hopefully we'll get through it pretty quick. First of all, I thought I might just bring a couple of words back to the surface of algebra. Think about an algebraic expression versus an equation. An expression has just or is made up of terms, but there's no equal sign. An equation has an equal sign. So at the moment in this red bracket here, you can see I have an expression. Now this is made up of 4 algebraic terms. Remembering that 3 is an algebraic term, just doesn't have any algebra associated with it. But think about things like x to the power of 0, anything to the power of 0 equals 1. So technically speaking, this could have been 3x to the power of 0. Okay, so it is still considered an algebraic term. So I've got 4 algebraic terms. That plus 3, we might remember the word that is called the constant term. The constant term. You might remember that the 5 or the 6 or the 2, they are called the coefficients. That's always a fancy word to remember. And of course, the letters, okay, are often what we call the pronumerals. The pronumerals, sometimes we call them the variables because they change, okay? And then probably the other thing I want to talk about is when you have pronumerals or variables that are the same, we often call those like terms. So remembering things like 5a plus 2a, we would say that those two things are like terms because we know that we can now add those together, we can collate them. For example, if I add those together, we know we have got 7a there, okay? All right, going to be pretty quick. I'm just going to go through a couple of examples, nothing too challenging. It's all a bit of review for you guys today. Please make sure you write these notes down in your book. Very important, you've got these notes there, and then you can go along with the exercise questions for today. Okay, the first one, I'm going to circle the like terms. We have a 5a, we have a plus 6a. Well, that makes 11a. I'm going to subtract 3 of them. Well, 11 minus 3 makes 8a. So I'm going to add those together. We get 8a's. And then we have this constant term of plus 2. So that becomes just at the end there. We can't add them because they're not like terms. And that's simply my answer. I simplify it down to having an expression of 2 terms only. Beautiful. All right, the next one. Now, you might see why I've made this one a little bit more challenging. We now have a squareds and a's. Hopefully we remember that the a squareds and the a's are different terms because one means a squared, a times a, and the other just means a. So in this case, we're going to add the 5a squareds with the 3a squareds to make it as 8a squared. And then I'm going to put the minus 6a next to it. And again, I simplify it down to having just 2 terms in my expression. Perfect. The next one. Okay, hopefully again you remember these ones where you have the x, y's and the together like that, for example. All right, and they are the same term. Now, in fact, if I had said 5xy plus, or let's say we'll keep with the minus there, minus 3yx, they're also the same term because x and yx, they're just being times together. It doesn't matter which way we do those. For example, 5 3s are 15, 3 5s are 15, has no bearing. So I'm going to take those away from each other. So I'm left with 2xy's. I've got a plus 2x, there's no other x's there, and I've got this plus 4, that constant term. So now I simplify it down to having just 3 terms in my expression. Perfect, that's my answer. Might do that one in yellow, we can move on. Okay, now I go into multiplications. Okay, now multiplications, remember, these have actually got multiplications in between every single thing. So, for example, that's 5 times a times y squared times 3 times a times y. Now, it doesn't matter which way I do these multiplications, as we just saw. I'm going to do the numbers first. 5 times 3 makes 15. Perfect. I now have a times a. Well, that makes a squared if I times them together. And then I have y squared times y. That makes y cubed. Job done. Got my answer. That is a nice simplified term. Okay. Now, the next one. We have 5a cubed all squared. Now, 2 ways to do this. Do you remember the rules? I call it the inside-outside rule. So that if an index is inside the brackets, one's outside the brackets, we multiply these together. Now, for example, we have 5 to the power of 1. So 1 times 2 makes 2, so we get 5 squared. And then we have 3 times 2 makes 6. This makes 25a to the 6. Now, alternatively, if you think you're going to forget that, you can just write out 5a cubed times 5a cubed, because that's what it means to square itself. And now you can still see the 5 times 5 is 25. I'm going to add the 2 3s to make the 6 there. So a lot of this does try and churn up a little bit of indices laws as well to make sure that you remember some of those important factors that we learned in year 8 and year 9. Okay, second last one, or third last one, I think. We have a division. Same thing, we're going to do 10 divided by 30 first of all. Now, be careful here because it's going to be a fraction, because 10 divided by 30 doesn't make a whole number. So what we can actually do, we can simplify that to being 1/3, 1/3. Now, what do you do with the indices when you are dividing a common base? Well, we subtract those. So 6 take over 1 makes 5. So we have a to the 5 on top. You can also think about it as you're getting rid of 1 on the bottom and you're getting rid of 1 on the top. We're left with a5. Likewise, we have 1 y on the top and 4 on the bottom. If we take 1 off the top and 1 off the bottom, we're left with 3 on the bottom. Now, technically speaking, gents, you could have had 1 on 3, a to the 5, y to the -3, technically, but we like to have simplified terms without negative indices. So I'd really try hard to put that on the bottom to make sure we have a positive indice. Okay, I don't really want the negative there, albeit it is the same thing. All right, the last 3 questions here. We're going to be looking at some expanding of brackets. So I call it the rainbow effect. 5a times 3a, that makes 15a squared. We have 5a times -2, that makes -10a. I'm simply expanding these brackets out, and I can simplify if it's possible, but in this case we can't because they're no longer like terms. The next one, love this question, okay, because a lot of people get it wrong. They try and do the 4 minus 3 first of all. Hopefully you didn't do that. Remember BIDMAS. Brackets, not much I can do there. Indices, no indices. Multiply or divide, whichever comes first. Yes, I have a multiplication here. So we need to multiply the -3 out with a 2a. That makes -6a. I multiply the -3 out with a +1. Makes it -3. Be careful there. So I've multiplied the brackets out, but now I can simplify because you can see here that we have 2 constants that we can add together or subtract. So 4 minus 3 makes +1, and I've got the -6a, and that becomes my actual answer. Okay, how many of you did 4 minus 3 is 1, and so we gave the answer of 2a plus 1. Be very careful. The last one, again, similar thing, -3t times 3t, well that makes -9t squared. And then -3t times -2 is going to be, well, a negative times a negative is a positive. So we get a positive 3 2s as 6t. Okay, make sure your t's don't look like pluses. Okay, that's it. So again, gents, this is a very quick lesson, just reminding you on how to do your simplification of algebraic terms. If you need to watch the video again, please do so. Otherwise, go to the questions, have a crack at it, and I'll see you for the next lesson.